the rectangular coordinate system. We're going to work on the rectangular coordinate system, which consists of two number lines which intersect. The x-axis goes across, looks like a regular number line. To the right is positive, to the left is negative. The vertical number line or axis is called the y-axis. The up part is positive, the down part is negative. We're going to plot points on this rectangular coordinate system that have two directions, an x direction and a y direction. To plot these points, we will start at the center. This is called the origin, and its coordinates are 0, 0. You have not moved across, you have not moved up or down, so you're staying right here. The points we plot on this rectangular coordinate system are called ordered pairs. An ordered pair is a pair of numbers where the order matters, such as the rectangular coordinates x and y, where the first coordinate represents the x coordinate and the second coordinate represents the y coordinate. We're going to plot some points on this rectangular coordinate system. Remember, the first coordinate is going to be x, the second is y, and the parentheses is part of the notation. So when you see this with the comma in between, you know this is an ordered pair to be plotted on a rectangular coordinate system. So we will start at 0, 0, and we will first move for the x. So we're going to go across 1, 2, 3. We don't make a point until we finish. Now we're going to move the y direction, which is up and down, positive 1, so we'll go up 1, and we'll make a point, and that is the point 3, 1. Let's try another point. What if we did negative 3, 1? We would start at 0, 0. Our x is negative 3, so we would go to the left 3, and then our y is positive 1, so it would be up here. We make the point when we're finished, so this is negative 3, 1. What do you think we would need to land down in this section? We would need negative on both of them. So the point that matches our others is negative 3, negative 1. So we start at 0, 0, negative 3 on the x, negative 1 on the y, then we make our point. The points that you have to just be a little more careful about graphing are points that land on the axes themselves. So let's try first 0, negative 2. So we're starting at 0, 0, and a 0 for x says you don't go across, you still sit there. And then we're going to go down 2 for the y, and so it will land here. So just if you have a 0 for the x, you don't move across, you just sit still. So this is 0, negative 2. And if we do 5, 0, we start at 0, 0. It says move 5 on the x, 1, 2, 3, 4, 5, but don't go up or down. So it's going to stay right on the axis. So this is 5, 0. If you have an improper fraction, graphing is a place where it's easier if you change to a mixed number rather than cutting things into a lot of halves. So we will divide to change 7 halves into a mixed number. 2 into 7. We'll go 3 times. 3 2s are 6, and we have 1 left over. So 3 1/2. 3 1/2 is easier to locate than 7 halves. So we will start at 0, 0, and we're going over to the right, 1, 2, 3. And for the half, we're just going to guess. It will be halfway between 3 and 4. So that's about halfway, and then we're going to go down 1 for negative 1 and make our point. So you certainly could do a fraction. If you have an improper fraction, it's easier here to switch to a mixed number, do 3 1/2 and negative 1. Some questions are a little backwards thought process. They might give you the point and ask for the coordinates. So if we wanted the coordinates of this point, we would just go to 0, 0 and move to it. So first we would move across, and negative 4 lines up with it, so that will be our x. And then we're going up 2, so that's a positive 2. So negative 4, 2 is our coordinates. The rectangular coordinate system has 4 separate sections. These are called quadrants. They are numbered counterclockwise, often with Roman numerals. So this is quadrant 1, 2, 3, and 4. Often you'll have a general question for a quadrant. So which quadrant contains, they might give you a large point, so negative 750 and 341. Something you really wouldn't want to graph, but just to find which section it falls in. So first we would have a negative x, and then we're going to have a positive y. So it is going to fall in quadrant 2. Here's one more quadrant question. Which quadrant contains x less than 0? So if x is less than 0, then x is negative. So x is across, so it's going to be less than 0. Puts it on this side. So it could be quadrant 2 or 3. There is no restriction on the y. Next, we have some questions that relate the graphing back to the algebra. It says, determine whether each ordered pair is a solution of the given linear equation. So this is really 2 questions. It's asking if these points after the semicolon are solutions for this equation. So first of all, it's asking, is 3, 1 a solution for this equation? Does it make it true? And remember, the first one is our x, the second one is our y. So we're just going to substitute, like an evaluate question, into our original. So we're going to keep the 2. It needs to be times the x, which is 3 plus, and then we'll plug in the y, which is 1 equals 7. We don't know if this is true or not, so we're going to work it out. 2 times 3 is 6, plus 1 does equal 7. So for our first one, the answer is yes. 3, 1 is a solution for this equation. What that means as far as graphing is when you draw the picture of this equation, the point 3, 1, because it makes it true, will land on that picture of that equation. Right, so let's try 7, 0. We're just going to start over. It's a separate question. We're going to plug it in. So we have 2 times, we'll plug in the x is 7 plus 0. Is that equal to 7? 2 times 7 is 14 plus 0. This one is not going to be true. 14 does not equal 7, so we would say no. If we had the picture of this equation, 7, 0 would not land on this picture because it makes it false. This time, instead of asking us if an ordered pair makes the equation true, they're going to have us force it to be true. So we're going to complete each ordered pair so that it is a solution of the given linear equation. So again, we have 2 questions here. This is just the way they're writing the questions. And for the first one, they have given us one of the coordinates but not the other. So if they gave us the second one, they gave us y. Remember, first one is x, second one is y. So they're giving us the y. We're going to plug it in and solve for the x. So we have x minus 4 times negative 2 equals 4. So there's only one unknown. We're going to force it to be true. So minus a negative here, this is going to be plus. And to isolate your variables, subtract this 8. So we have subtracting 8 from both sides. X equals negative 4. So negative 4, negative 2 will make it true. We have forced it to be true. So negative 4, negative 2. Right, let's try one more. For the second one, they are giving us the x coordinate. They gave
us the first one. So we're going to go back to the original and plug it in. So we have x, which is 4 minus 4 times our y, which we don't know, equals 4. So we plugged in the 4. That's what we knew. We did not know why. We're going to force it to be true. So we're going to subtract this 4 from both sides. Lots of 4's on this one. Negative 4y equals 0. Divide by negative 4. So you get y equals 0. 0 divided by anything is 0. And so our ordered pair there, that makes it true. The x was 4, and 0 is the y value. This is another format for asking the same question we just did. Often you will see things in a table because it makes it more compact and the data is more organized. So complete the table of ordered pairs for the linear equation. Same equation, and they're giving us the negative 2. So you plug it into the y. So x minus 4 times negative 2 equals 4. There's your 8. And subtract your 8 from both sides. So this is the same one we already solved, so I went a little fast there. And then they're switching and they're giving you the x value. So we plug the 4 into the x. And we subtract the 4 from both sides. And divide by negative 4. I'm out of room, so it's going to equal 0. But
this is the same question we did on the previous screen, just written in a different format.